going to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
My name is Alexei Ledenev and I'm from Israel. A few years ago, I've met the concept of chaos testing for the first time, and it resonated well with what I was doing. I failed to find any chaos testing tool for Docker containers, so I've created an open source project called Pumbaa. And today I would like to share my thoughts about chaos testing for Docker containers and how you can use Pumbaa to simulate failures, network issues, and stress test your containers.
Okay. Hello guys. Today I'm going to talk about chaos engineering approach for testing application resilience of distributed system built on top of containers and running on container clusters. So let me introduce myself. My name is Alexei Ledenev. I'm staff cloud architect at Do-It International. I also an open source developer running multiple projects. Like Pumbaa, this is the project I will talk today about. Also have kubesm agent running systems manager on Kubernetes, G-token. This is server passwordless connection between Google Cloud and AWS, and some other projects. As you understand, I'm actually working with containers and Dockers and Kubernetes for last 4 or 5 years. And my current technology stack is all about cloud and containers. It's AWS, Google Cloud, writing in Golang, some shell scripts, but mainly, again, containerized environments and containers and distributed systems. So software development is about building software services that should support different business needs. And the more complex business processes we want to automate and integrate, the more complex software systems we are building. And these solutions tend to grow with complexity over time and scope. Some systems tend to handle too many concerns, integrating with external and internal legacy systems. They're written and rewritten by over several years by many people at different technology skills, with constantly changing business requirements and different technologies following different languages, technology, and architectural trends. So my point that is building software that is unintentionally become more and more complex over time is easy. And we all have done this, and there are many teams that are doing it right now. Building a good software architecture for a complex system and keeping its good abilities for some long period of time is really hard. When you have too many moving parts like integrations and changing requirements that lead to code changes, security updates, hardware modernization, migration to the cloud, multiple network communication channels, etc., it becomes a mission impossible to avoid failures. Sooner or later, any complex system will fail, and software systems are no exception. Failure can occur anytime and almost anywhere, so you should never get too comfortable. And just to give you example, that all systems fail, and even most, systems from most stateful and respectful services from big companies that practice CI/CD have a high percentage of automation, DevOps procedures, practicing test-driven development, BDD, have a huge QA department and very well-defined release procedures, they also fail. And just from this year, if I give you some example, AWS, for example, in January this year, they have outage for more than 8 hours of the whole region failed in Sydney area. And this is due to bugs in their DevOps toolchain. And then later on in March this year, Azure failed in US East data center. Multiple services of Azure cloud services failed. And after a few days, Microsoft disclaimed that it was a failure in the cooling system that leads to this cascade failure. And then Google Cloud. Failure in Google Cloud identity and access management systems locked users out of the multiple Google Cloud services like App Engine and Cloud Function and BigQuery and even Cloud YAS. And it lasted for 2 hours till it was fixed. GitHub, if you use GitHub, you can remember that in April, again, there were multiple failures in GitHub, and GitHub was not available for a long period of times. Adobe Creative Cloud, all Adobe Photoshop and Creative Cloud services were not available for cloud users for more than 1 day, 24 hours, and Adobe didn't disclose what was the reason. IBM Cloud, again, due to mislead DNS configuration by third-party vendor, lead to the problem with multiple sites, multiple applications hosted on IBM Cloud, and it took them several hours to fix these issues. And big names like Cloudflare, Apple, Samsung. And actually, there are multiple sites that try to collect this kind of reports. If you visit the outage.report site, you can find their daily reporting, people reporting hundreds of thousands of failures on multiple services, multiple regions. And it happens constantly, okay? And so, as a software engineer and software tester and developers, we want to be proud of the software systems we are building. We want to be them of high quality, without functional bug, without security holes, with exceptional performance and resilient to different failures, self-healing system, always available and easy to maintain and change. But and every project starts with this high quality goal in mind, but very few, if any at all, are able to achieve and keep intact all abilities. We have to be realistic, but also kind of optimistic and try to keep this goal in mind and learn how to get closer to it over time, step by step. So what we can do to improve system quality, to achieve better system availability and resilience to failures. So should we do more testing? Probably. And better monitoring? And yes, of course. People do functional testing and performance testing, integration, acceptance, penetration, security testing. All this testing is important. But more testing also sometimes has a destructive effect, and they slow down R&D velocity and business agility. Don't get me wrong, testing is very important and you should practice it. But when you have slow and fragile testing and that don't add any confidence and this can bring more drawbacks than benefits. And most existing testing today are focused on functionality and performance and security, but they don't test your system against unexpected failures in production usually. Testing during a CI phase or QA in QA environment or CI environment is not enough. This environment usually are very different from the real production environments. Again, probably monitoring can help here, and monitoring and logging, these are essential, like things like practice like log analytics and failure prediction and monitoring alerts. But all these are kind of passive quality gates. Relying on log and monitors, you will always miss the train. Okay, but hopefully you can find the reason behind the failure. So you should do this. Try to use all these tools and all these practices. Today, building distributed software architecture and building distributed software system is much easier than ever. We have all new amazing technologies and experience we gathered, and the microservice architecture is a reality nowadays. And different container technologies we have, they just support this kind of architecture. So it's much easier to deploy, scale, link, discover, update, and manage distributed system composed from multiple microservices or service components. So we know how to build and scale highly distributed systems, but which takes me to the next slide, which is called CAP theorem. So CAP theorem is a theorem formulated by Eric Brewer and was formulated and proven by Eric Brewer. And it states that from the three properties of shared data systems, consistency, availability, and tolerance to network partitioning, only two can be achieved at any given moment of time. But I would state that there is no distributed system that want to live with partitioning. And if it does, it's not called a distributed system. So we need to find a way how to test and check our system for partition tolerance. And this means that some system components, system services, or connection between these components can disappear or can be disrupted over a long or short period of time. And we need to find a way to test how our system behaves in these situations. And I believe that chaos engineering practices, they actually allow us effectively test systems for partition tolerance. And what is chaos engineering? So the term itself was initially introduced and popularized by Netflix company. And Netflix were pioneers in building highly scaled, highly distributed video streaming services running on public cloud, on AWS. And the idea behind the chaos engineering was pretty simple. Embrace the failure, okay? You need to live in a situation that failure will happen. 100% it will happen. So you need to be ready. And chaos engineering tried to define an empirical approach, engineering approach to resilience testing of a distributed software system by defining the chaos experiment, which actually, first of all, you try to define the normal or steady state of your system by analyzing and collecting different monitoring metrics that represent the system, or maybe business related metrics, also underlying infrastructure metrics. And then you pseudo-randomly inject in a controlled manner, you inject failures like terminating virtual machines and killing containers, changing network behavior, inserting configuration errors, stressing the resources, etc. And then after you inject these faults, you try to discover system weaknesses by analyzing deviation from the expected or steady state behavior. The harder is to disturb the steady state, the more confidence you will have in the behavior of the systems. I invite you to visit the principle of house.org site that formulates the ideas and manifest behind the chaos engineering in a pretty good way. So of course it's possible to practice the chaos engineering manually and rely on automatic system updates and shut down the VMs manually on kill processes. But actually we as engineer, we like to automate things, and there are some nice tools. And one of the first tools that was introduced again by Netflix was Chaos Monkey. Today it's called Simian Army, a set of tools. And what Chaos Monkey knew to do from the very beginning, it could kill EC2 machine on AWS and can kill processing within this machine and burn a CPU, fill disk, detach volumes, inject network failures, and accompany tools like ChaosConf even could remove the whole region, AWS region, from the environment. And I like the tool. And when I started my container-based project 4 or 5 years ago, it looks like I expected the tool, and it looks like tool provided the raw granularity of chaos I wanted to create. Okay, and I needed chaos not at the VM level, but at the container level, and even be able to reproduce faults on developer machine, on single machine, not only in the cluster. So I went to Google and I start to search Google for Chaos Monkey for Docker. So I search, but I didn't find anything besides some bash scripts and manual how-to descriptions. So I created my own tool, and it happens to be quite a useful tool from the very beginning. I contributed it to open source community under friendly Apache open source license. And I get back interest from the community people and contribution in terms of enhancement requests, issues, and pull requests. And it was a kind of Chaos Monkey for Docker or Chaos Warhol. Just a minute.
Hey, are you talking to me? Are you talking to me? Shouldn't have done that. Are you talking to me? Now they're in for it. Hey, call me Mr. Pig.
So the tool, I gave it the name Pumbaa, and those who grew in 90s know that Pumbaa is a well-known supporting character, Warthog, from Disney animated movie The Lion King. But it has another meaning. In Swahili, African language, Pumbaa means to be foolish, silly, weak-minded, careless, neglected person. And this description match actually the project goals I wanted, or the tool I wanted to create. It's also, so it becomes an open source chaos testing tool for Docker container. It's hosted on GitHub. You can search for Pumbaa, you will find it there. And it's a single binary executable without any dependency, just copy binary to the system's path and you're ready to go. It has binaries for any platform like Linux, Windows, Mac. It also have a Docker images, can be run on the Kubernetes, and support multiple process architecture like Intel 64 or ARM 64, including multi-archive Docker images, meaning if you pull this image on the Docker host which is running on ARM, it will fetch the appropriate image. So what Pumbaa can do? Pumbaa can actually uses Docker API and can disturb Docker runtime environment on local or remote machine, injecting different failures. The victim container you're trying to disturb can be specified by providing a name or list of names, regular expression, or labels attached to the container. And you can inject randomness by providing a random flag. So only one of provided container list will be selected at random. It's possible to define a repeatable interval when the chaos command will be executed and duration for how long the chaos will be executed for better control of the chaos itself. And Pumbaa can start either a single host, as I said, or the whole Kubernetes cluster, and I will demo it later on. So starting with the basic commands, what things can be done? So the stop command actually stop running a Docker container with optional auto restart. And kill command send a termination or other Linux signal to the main process running within the Docker container. Remove can remove a target container, remove their links and their volumes, and pause actually goes into the container main process and pause it for a specified time period. So just to show some examples, and I also show a demo. So this command will stop random container once in 10 minutes by running Pumbaa random interval 10 minutes and sending a Unix signal 6 stop to any container on the local host. This is what command does. Another example, you're running two Pumbaa commands. The first one, once in 15 minutes, in interval 15 minutes, sending term signal MySQL container. And the second command, once in an hour, just go and remove any containers that starts with CF, whatever it means. And or for example, every 5 minutes randomly kill worker 1 or worker 2 container, sending kill signal, and pause every 3 minutes for 15 seconds, pause the queue container running some message queue. These are examples. So let me switch to the demo. I hope you see my screen. So I will demonstrate the kill demo. So in the kill demo, I will run 10 Docker container doing nothing, just it's running tail command. And I will run also a Pumbaa kill command, just go and randomly kill a container, starting code kill me something every 3 seconds. So let's run it. So I'm running the containers, and sorry, it's my problem. I need to start Docker for this demo. Obviously, it was not running. Okay, waiting a bit, and right now again. Okay, so I'm running, creating 10 containers. And you can see these containers, all containers up and running, doing nothing. And they call kill something, kill number. And then I'm running a Pumbaa kill demo. And you see it start killing containers one by one, selecting a random container every time. So you see that some containers start to exit. When I stop Pumbaa at any time, it will stop running the chaos command, and I can finish my demo. So let's, the next one will be faster since Docker is already running. Another thing that Pumbaa can do is to simulate different network failures by running a network chaos command. So can emulate network failures at the container level, optionally filtered by target IP. And the delay command can delay all egress traffic for the specified container. Loss command can add packet loss based on different probability loss model. It can be Markov loss model or Gilbert or simple Bernoulli, Gilbert and Bernoulli model. Rate limit can simulate network speed for all egress traffic. Duplicate, just duplicate TCP packets and corrupt TCP packets. So all this command allows you to simulate wide area network issues or networking issues. So for example, you can see the first command actually add a 3-second delay to all outgoing packets on a default network device in Docker container called MyDB. Running the netem delay for 5 minutes, and I'm actually adding a 3-second delay. It's in millisecond. More advanced command, you can also specify the network device using interface flag, and you can also add the jitter, plus minus 30 milliseconds, for example, in this example, and correlation to the previous value, like 20% to the previous value of the delay. And I'm delaying traffic to all containers starting this word test. And the last one showed the same example, again, using the normal distribution and on free containers provided by a container list. So let's do a short demo for delay. Yeah, it will be okay. So switch back to my console. And I will show what I'm doing in delay. I'm just running the Docker container, sending ping to Cloudflare DNS. It's pretty straightforward. So what I'm doing, and you can see it start pinging Cloudflare DNS with around 50 milliseconds ping time. Now I will run the Pumbaa delay demo. It will add, actually, for 10 seconds, it will add delay of 3 seconds to the all egress traffic. So let's run it. And pay attention, it should start apply the delay right now. As you can see, for 10 seconds, all traffic will be slower, and then it will the speed will be restored automatically. Again, it starts the delay again, but if I stop it, it will actually stop the delay and restore the original properties of the network. So how does it work? How Pumbaa creates network emulation for container? Actually, Pumbaa uses something called traffic control. It's part of the Linux kernel that provides this traffic control for routing, bridging, firewalling, and moving packetting between Linux hosts. before packet leaves the output network interface, it passes through Linux traffic control. And this component is actually a very powerful tool for scheduling, shaping, and actually prioritizing and modifying traffic in the Linux host. The basic component of traffic control is called queuing discipline. And the simplest implementation of queuing discipline, for example, is first in, first out, meaning first packet that arrives the network interface is the first packet that leaves the network interface. But there are multiple queuing disciplines too. And one of these queuing discipline, it's called network emulation. A network emulation queuing discipline allow you to emulate wide area network properties like latency, jitter, packet loss, duplication, corruption, packet reordering, and many more. And actually, Pumbaa utilize this Linux component and uses a traffic control tool, TC2, to inject a network queuing discipline into container network device. It does it by attaching to the Docker container network namespace and inject and running the queuing discipline commands. Again, if a container has a traffic control command line tool on board that can use the one provided inside the container itself. If not, it can bring the additional Docker image and inject it into the target container network namespace and execute all required commands to create these different network failures. Another thing that was introduced about a year ago, was a stress container. Pumbaa can actually stress container and can disturb Docker containers with wide area range of different stress mechanisms. And under the hood, Pumbaa actually injects and orchestrates statically linked stress ng tool into Docker container control group. Control group is the second part of the Docker container technology or any container technology. It actually defines the resource available for the container. And once you inject a stress tool into the same control group as your target container, actually any resource that you are consuming, actually you are consuming from the target container. Okay, and stress ng tool support over 200 different stressors, and using it you can stress CPU compute and CPU cache and the device, block device, and any other device and file system, IO devices, memory, throughput, RAM, paging, networking also, and kernel system calls and security calls, etc. A lot of things and it's the number of stressors are always added with additional stressors. So Pumbaa supports any of them. And just to demo it, so let's back to the console. And I will run the stress demo. And in the stress demo, I'm running a container that's doing nothing. Okay. Running the tail command. And as you can see, it has a 0 CPU, it's a 0, and memory usage is 400K. It's pretty low. It's just an Alpine image doing nothing. Okay, so I'm running the Pumbaa stress command, stressing CPU and memory, taking 1 GB of memory and stressing all available CPU. And on my machine, I allocated from the 12 CPU I have, I allocated 6 CPU to the Docker engine. So we should see around 600% stress usage, CPU usage, sorry. So I'm running the stress, and you can see the new stressor container is created. It's not doing anything, but the target container, test me containers, suddenly you can see that the CPU usage hikes to almost to 600%, and the memory usage grows to 1 gigabyte. Okay, so I'm stop this stress. And let's talk about, I have 5 minutes to finish. So let's talk about Kubernetes. And one disclaimer, I'm working on Kubernetes native controller operator for Pumbaa, which will allow you to define the chaos test as Kubernetes objects. But currently, the way to run Pumbaa is actually run the pod with Pumbaa on board. One of the optional model is to run a daemon set using daemon set deployment model. And using daemon set, you can make sure that Pumbaa is automatically deployed on all nodes in the cluster, or some nodes in the cluster. I will talk about it later. Okay, and you can specify multiple Pumbaa commands within the deployment. And Pumbaa itself is a very lightweight Docker container, just few megabytes, and very lightweight in resource consumption also. You don't need to provide too many CPU and memory for Pumbaa to run. And it can create a load on, it can actually disturb the Kubernetes containers using a label filter. Since Kubernetes automatically add labels to the all Docker containers. And for example, it add label called IO Kubernetes pod name, which actually pod name. And you have also label for namespace, and you have also additional labels there that Kubernetes injects automatically. So you can use this label to create to disturb specific pods or specific namespace, specific workload. You can you can run it on all nodes or on specific nodes using Kubernetes node selector or node affinity configuration for daemon set, Pumbaa daemon set. And let's demo it. I have time, so probably let's try to demo it. So for this, I will need 2 console to the client. So in one, I will run command that is running pod and printing time every second, and in other, I will run command that is pinging again Cloudflare DNS. At the bottom line, I will run a daemon set. You see daemon set, which has 2 Pumbaa containers on board. One is running the pause command for 10 seconds, and other is running a delay targeting a pod named test2, and the first one target pod named test1. So I'm running a demo. It currently deploys the Pumbaa daemon set on my Kubernetes cluster, and okay. And you should be able to see that one pod delay is injected, and in other pod, you could see that was a 10-second skip between printing time. So the process in the second pod was paused for 10 seconds. Okay. So when I kill my deployment, actually, the original network configuration restored and the process is unpaused. So it was the Kubernetes demo. And again, the project itself is an open source project. It's available on GitHub. Please give it a try. Go try to work with it to test your application for partition tolerance, for your containerized application for partition tolerance. Report an issue if you see any issue, contribute a feature request, propose new ideas, contribute a pull request. I'm ready to accept any, and give it a star. Also, Docker image for Pumbaa is available on Docker Hub. It's multi-archive Docker image. You can pull it from the Docker Hub. Okay, it's already have more than 5 million pulls. And I invite you to follow me on Twitter, Alexei Led, and on Medium. I publish their blogs and post about containers and Go language and cloud technologies. Thank you, guys. I'm switching to questions.